Welcome to the course RF Transceivers, Unit 1, CMOS Basics, Transceiver Specifications and Architectures. Topic is CMOS, Introduction to MOSFET Physics, and noise, short noise, flicker noise, popcorn noise. The objective of this presentation is to provide an overall view of CMOS technology and to explain the basic concept of MOSFET in the context of RF transceivers, and then to understand the different type of noise present in the RF transceiver. Introduction to CMOS technology. CMOS means complementary metal oxide semiconductor. This technology is widely used in semiconductor technology in modern integrated circuits. The CMOS consists of both N-type MOSFET and then P-type MOSFET. As N-type and P-type are complementary to each other, that's why the circuit is called as CMOS. That means it consists of both N-type MOSFET as well as P-type MOSFET. The major advantage of CMOS technology is low power consumption, because as the CMOS is having high input impedance, it will draw less current, so it will have very low power consumption, and then it is having high integration density. That means in a given space we can integrate more number of CMOS devices as compared to other technology. So it is having high integration density, and then it is having compatibility with the digital circuitry. So these characteristics make the CMOS technology to be suitable for RF transceiver. Next, MOSFET basics. As we know, MOSFET means metal oxide semiconductor field effect transistor. It is a 3-terminal device. They are source, drain, and gate. Usually the gate is separated from the channel with help of the oxide layer. Then the MOSFET works under the concept of electric field. That means by applying the voltage to the gate terminal, we can control the current flow between the source and the drain. So say this is a MOSFET transistor, this is source, gate, drain. By applying proper voltage to the gate terminal, we can control the current flow between the drain and source. So as the voltage contributes to the electric field, finally the electric field controls the current flow between the drain and source. So that's why these transistors are called as field effect transistors. MOSFET operates in 3 regions, that is cutoff, triode, and saturation region. That depends on the what is the voltage applied between the gate and the source terminal. Then how to use MOSFET as an amplifier? We know that amplifier can be designed with help of any transistor. Say usually used to design amplifier with help of BJT, but now here we are designing amplifier with help of MOSFET. So MOSFET is also a transistor that can be used to design amplifiers in RF transceivers. So MOSFET usually operated in the saturation region. When we want to use it as an amplifier, MOSFET has to be operated in the saturation region. We know that for any amplifier amplification, the device has to exhibit linear relationship between the input and output. Then only we will get the output without any distortion. So when we use MOSFET as an amplifier, definitely we have to operate in the saturation region to exhibit the characteristics of linear relationship. But whereas in case of BJT to design amplifier, the BJT has to be operated in the linear region. But in case of MOSFET, it has to be operated in the saturation region. So the linearity is the crucial for maintaining the integrity of the RF signal. Then MOSFET can provide gain and then mainly proper impedance matching. And impedance matching in the sense to design a perfect amplifier, we must have proper input impedance, then output impedance. So for a good amplifier, usually it should have high input impedance and then low output impedance. By default, this MOSFET is providing these characteristics. So it is used for impedance matching. Inherently, to provide the impedance matching both at the input and at the output. So it is having high input impedance. It's because as the gate terminal is insulated from the transistor, the current flow in the gate terminal is very, very low, the order of microampere. So it is exhibiting very high input impedance at the input terminal. Then the small signal equivalent of the circuit model is used to design the RF amplifier. What are the advantages and challenges of CMOS technology? So it provides low power consumption. We know that as it consumes less current, it will have less power dissipation, so that it can be operated with the battery powered devices. And then easy integration with the digital circuitry. So it provides seamless integration of RF and digital circuits on a single chip, reducing the complexity and cost effectiveness and scalability. So nowadays the CMOS fabrication process are mature and cost effective, so that we can very easily do the mass production and scalability. Then what are the challenges associated with the CMOS technology? It is having limited power handling capability. So as compared to other devices, it is having low power handling capability. And then the linearity issues at high frequencies. Just now we have seen that linearity is the important factor in the design of any amplifier. But when we operate the amplifiers at high frequencies, it exhibits the nonlinear behavior. So nowadays the ongoing research aims to address these challenges. The next topic is noise. In that we'll see short noise, flicker noise, popcorn noise in the RF transceiver. So the objective of this presentation is to provide the understanding of different types of noise, including short noise, flicker noise, and popcorn noise in the context of RF transceivers. And also at the end of this presentation, we'll see what is the impact of the noise in the design of RF transceiver, and also how to mitigate the effect of these noises. Introduction to noise in RF transceivers. What is noise in communication system? Any unwanted random variations or disturbances in the electronic signals, we'll call it as a noise. Ultimately, these noises or disturbances will degrade the performance of the electronic system. So it is essential to understand the different types of noise, including these noises: short noise, flicker noise, and popcorn noise in the RF transceiver design. Short noise in RF transceivers. So short noise arises in the RF transceivers due to the statistical variations in the arrival of discrete charge carriers, then finally affecting the performance of the receivers. It is present in any current carrying conductors such as transistors, amplifiers, and mixers. And then short noise increases with the magnitude of the current, so that ultimately it affects the performance of the system, such as signal to noise ratio. See, the short noise is directly proportional to the DC current that is flowing in the system. So the more the DC current, the more will be the short noise. The SNR means signal to noise ratio. Means what is the signal power, the noise power, the design of electronic system or communication system. We will always see that what is the ratio of signal to noise ratio, because whenever the signal is there, noise also will be there. But ultimately, we'll try to improve the signal to noise ratio. So if the system or receiver system is creating the noise, then it will degrade the performance of the receiver. So to measure the performance of any communication system, we'll define the noise figure. That means what is the ratio of signal to noise ratio at the input, what is the signal to noise ratio at the output. Means we take any system at the receiver side, then the signal to noise ratio is Si by Ni, then output signal to noise ratio is So by No. So in general, the So by No will always be less than or equal to Si by Ni. It is mainly because the receiver itself will add some noise. So definitely So by No will be less than or equal to Si by Ni. But how far this is very close to Si by Ni, so that our receiver is adding very less noise. That means any receiver will add some noise, but it should be as minimum as possible. Next, flicker noise. Flicker noise is also known as 1 by F noise, and it is a low frequency noise. Why? Because say the flicker noise is having transfer function like this. That means whenever the frequency value is low, the noise value, overall value will be high. So the effect of flicker noise increases whenever the frequency is getting decreased. So that's why this noise is known as 1 by F noise or low frequency noise. So predominantly it will occur at the very low frequencies. Then the main reason for this flicker noise is surface imperfections. Then this noise, flicker noise, is also called as modulation noise because of this nature, because whenever the frequency is decreasing, the value is increasing, noise value is increasing. That means so some kind of variation, modulation noise. So the flicker noise can be a challenge in the RF transceiver design, particularly for low power and high precision application. Popcorn noise in RF transceivers. Popcorn noise is also called as random telegraph signal noise. So it occurs in the RF transceiver due to the defects or traps in the devices like transistors and capacitors. So it leads to the discrete changes in the amplitude or the behavior of circuit elements, finally affecting the RF system performance and stability. So this noise can be mitigated by means of careful device selection and optimization. Nice mitigation in RF transceivers. So understanding and managing noise in RF transceivers are critical for achieving the optimal performance, because whenever we design any transceiver, we'll always try to reduce the noise added by the transceivers during the signal processing at the transceiver. So the noise mitigation techniques specific to RF transceivers include filtering, shielding, impedance matching, and then proper component selection. So by implementing these noise mitigation strategies, the impact of short noise, flicker noise, and popcorn noise can be minimized, leading to the improved system performance. So the reference is RF Microelectronics by Razavi. Thank you.